Okay, just finished up the final version for the Gremlin Head-On, the original board. Head-On, not the Dual-VIC board, the original board. RAM test and ROM test. And this is how it turned out. We've got the RAMs checked. If you see this screen, that means all the RAMs are good. Then it reads all the checksums and all the ROMs and tells you if they're good or if you've got a bad one. If you've got a bad one, it tells you what checksum it read. And then the inputs, the input section down here. Anytime you change an input, you'll see me zoom in. Maybe it'll be easier to see. Whoop. Come on, telephone, or zoom in. Now I got a black mark there. Come on. Zoom out. Come on. Wonder why I have that black mark there. There we go. Oh, try that again. Okay. All right, well, maybe you can see it through the mess. So anytime you change the input, it changes to the number of the input that you're actuating. Really wish I could get that to focus. Wow. Zoom way out. Okay, there. Well, oh, this is messed up. Should have picked different colors, huh? Now, if I zoom in, it makes it all white. Why is that? Or it adds that black crap in there. Anyway, so you can see how that works. The last input number that you push is displayed. Also, the audio board, whatever the last button you pushed will be lit. And if you push more than one at the same time, only the lowest number is displayed. So the idea is you'll have this board in your machine, right? And you'll put this test chip in, and you can check your inputs, right? And each input will have a different sound associated with it. And also, if the sounds aren't working entirely, you can always look at the display to see what the inputs are doing. Now, this section here, like I said, it reads all the checksums, and it will display okay. You know, normally these would all be okay, and if it's bad, it shows you the checksum. This is more for my benefit than for, you know, your diagnosis. The checksum I'm talking about, that really doesn't make any difference. As far as repairing the thing, all you need to know is it's a bad chip. But for me, I can use that to get, you know, like if it's a good set of EPROMs, or if it's a new set of EPROMs, or an upgraded set, then I can get the code that I need to put into the assembly language to make that test pass. That's why that's there. But so I'm just going to talk a little bit here about how this whole project progressed. I've got another board that's right there. This one doesn't do anything. It will not run any code at all. So I thought if I had a test chip that I could plug into it, that might help me debug it. My version 1 I put in there, and it gave me no help. I'll put the version 2 in there. I don't expect it'll help either. But that was the whole motivation behind it, is to try to repair that board. But once I got started, it became just part of the hobby. The way this all progressed was, had the board and needed to fix it, wanted a test chip. There was none out there. No, there's nothing available that I could find. So I wrote a TICL program, tool control language. You can use Perl or whatever you want, C if you want. You can use whatever language you want. And basically I wrote my own assembler. Now there are assemblers out there, and I used one at first before I even wrote anything. I didn't like the way it worked, you know. I think it was Z80 ASM is what I used, and it works, but it does not fill in the data for you. Like I want my program, or the way I wrote my program, I should say, is I specify a command line option on the size of the EPROM I'm trying to burn, and it will backfill, you know, everything that's not being used by the assembly level program. So it puts Fs, you know, FF everywhere that there is an unused memory location on the EPROM I'm burning. So that was really the main motivation. Yes, I could have done it using Z80 ASM. I know I could have put code in the assembly to do it, but this is a hobby. I just wanted to see if I could write my own program. And I did. And yes, it had bugs, but that's all part of the fun, right? Debugging that. I think there's no bugs left in it. Of course, I haven't used every single instruction that it supports. Maybe there's something I haven't exercised yet, but if it ever comes across, I'll fix it, because believe me, there's been 10, bugs at least, I would think, in the program as all this has happened. And it's usually addressing modes that are screwed up, like the indexes are different than the immediates, which are different than the register modes. And I had to use a particular instruction. Also, there's different classifications of codes. There's loads and adds and logic, X and XOR and OR and. All that stuff is independent, individual code, and it has to be tested, to see if it works or not. But luckily for me, the Z80 is fairly simple. I think the longest opcode is 4 bytes, I think, and I probably didn't even use any of those. Those are probably special indexed and immediate something or another's, something like that. Maybe it's 5 bytes, I'm not sure. But anyway, the way the flow in this project went, I wrote a Tickle program, and then I wrote some assembly first, and then I wrote a Tickle program to process the assembly I had. And then it was just an iterative loop, as the pieces of code that I wrote were debugged, I was using it to debug the Tickle program, then I would expand on the assembly, and then I would find another problem and I'd fix it. And it was just an iterative process. And although this took me a month or more to do, I didn't do this full time. I had car repairs and I have work to do, I'm working. But this was just on weekends and some evenings. And I could have done it better, but I suck at this, so it took me a while. I'm also making a board. I'm manufacturing a board where I can put this 2716 in there. Half of it'll be 2 banks, because these are 70. These are 1Ks and this is a 2K. So this will be basically 2 2708s. Half of that of this EEPROM will be the test program. The other half will be the code for this chip, and then there'll just be a little switch, and I'll select which one I want. So that's where I'll end up. I guess I'll have another short video for that. This board here, not needed to use the program, but it is nice to see, to make sure that this chip here is driving that, and it's just nice to know that thing's fully working. But you can do the same thing if you put this in your cabinet. You can hear the sounds. Now, these lights flashing when it's going through the RAM test. Let me just run the RAM test real quick. So you can see the lights, they flash and stuff. Each one of those lights is going to be a sound, a different sound that comes out of your cabinet. And that's going to be annoying. But as long as you're hearing sounds, you know that the test, that the RAM test, okay, that flashing back and forth, that just tells me the RAM test passed. It kind of confused me there for a second, but yeah, that was normal. So yeah, each of those lights flashing is going to be a different sound if this is run inside a cabinet. And that's going to be annoying. I could take it out, but I'm never going to have a cabinet probably, so it's better for bench testing to have those on like that so I can see what's going on. That is about it. I do want to also write a similar program for Carnival, the Dual-VIC boards. But that's a different project than this one, but similar. I'll use the same Tickle program and also use the same assembly as a starting point. But I have no timeline on when I'm going to do that. It's just something I'm thinking I might do. Well, anyway, that's it. I can't complain. Looks pretty good. Works pretty good. I'm happy with it, and I will use it to fix that other dead board. And there'll be videos on that, I'm sure. Thanks for watching. I appreciate it.